Okay, so this is the second slide that will specifically describe the electronic part. As you know, I'm Luca Marchetti, and I will just give a brief introduction about me. So my office is in G331. I work as a postdoctor here at USN, and I was graduated in 2012 as a bachelor degree, master degree in 2015. In both cases, I specialize in electronics. In particular, my degree is in power electronics from Politecnico di Torino. And in 2017, I got my PhD degree. And then I've been also in charge as lab engineer at the electronic lab here at USN for 1 year. And I then become postdoctor until now. Yeah. My research interests are about junctionless transistors, memory stimulators, haptic ultrasound, neural prosthesis, and implantable electronic circuit. We have a lot of, I'm working with this project, which are very interesting, and I definitely think that is something that I'm very interested in. Motivation of the course. Okay, so here probably in class I did not explain too much. I was mainly concerned about giving other information related to the project and software, and also maybe my Norwegian skills were not um, very good for maybe going into this part. But I wanna maybe in this video also give a good overview about this part. Okay. I think that in our field, there are two types of electronic engineers, embedded system engineers and electronic circuit engineers. Embedded system engineers are those ones that work with systems, which means a microcontroller, Arduino, for example, or other embedded electronic device such as Raspberry Pi and FPGA, as you did in Digital Technique and so on. So if you think about it, what you are doing there is something like programming, right? An electronic device, and then knowing a few concepts about electronic, then you realize a system. So I would like to say that for performing this task, you just need a few concepts about electronic, very little, and then also maybe mainly IT knowledge about it. So programming. Instead, an electronic circuit engineer is someone that design customized electronic circuits by using electrical components. So it does not deal with programming anything. It just designs circuits. And it used the theory of the circuits, of electrical circuits to design systems. So there is no programming involved. This course aimed to teach you the basic techniques for becoming an electronic circuit designer, not an embedded system engineer. In particular, at the end of this course, you will be able to design analog mixed digital electronic circuits. In this course, we focus also our attention on design of power supply, and maybe I can use my pointer here. There it is, power supply. Verstärker, amplifier, and also design of printed circuit board. This is an example of printed circuit board with in short, we usually call it PCB. So at the end of this course, you'll be able to design this 3 different circuits. The point is that, in my opinion, and this was, in my opinion, make this course should make it quite interesting in respect to the other, is that IT engineers can actually become embedded system engineer because, as I said before, an embedded system engineer has to program an hardware or an electronic system, right? So use IT concepts, programming. And IT engineers, therefore, are the competition when you try to search a job in as embedded system engineer, of course. Because again, any other IT engineers can actually become an embedded system engineer if he just know a few concepts about electronic. It does not need to know very detailed electric circuit theory, right? But he maybe be more strong than you in programming because he's an IT engineer, right? So he's more familiar than you to IT concepts. Like for example, when you want to program Raspberry Pi, usually you use Python and you use Linux. You that you are an electronic engineer, have you studied physics, mathematics, and also other courses in microfabrication or something else, but you had not so much courses about programming. You are in disadvantage in respect to one that an IT engineer that instead have studied Linux, Python in multiple courses, right? So he has, from this point of view, I think, more advantage than you in finding a job, and it add competition. On the other hand, it is very difficult that an IT engineer will apply for a job of an electronic circuit designer. Because again, to become an electronic circuit designer, you need to have a very good knowledge about electric circuits and physics. In fact, the analog circuit designer know very well the physics behind and the logic behind the electronic circuits, which cannot be learned in short time. In conclusion, my point is that um, embedded engineer system is a very interesting field and very nice job. However, you will have always much more competition than electronic circuit engineer, which is actually what this course aims to teach you to become. So this course teach you to become a circuit engineer, and because this is what actually distinguish us as electronic engineer. We know how to use components, we know how to build circuits, and only us know how to do this because we have a good understanding and a very specific course that teach us about these concepts. So this is the motivation behind the course. This course aim to give you concepts, aim to teach you concepts about something that you only will own them. So you concept that only electronic engineer know, and will help you definitely, I think, to find a job in the real world. But only if you know them very well. If you just take this course for the sake of taking this course, then and you don't actually acquire all of this knowledge in yourself, then it doesn't really matter that you follow this course. So I definitely suggest you to give sufficient importance to this course. Because in my opinion is what again distinguish you from other engineers, and it definitely help you to find a job. Anyway, the content of the course I already went through very fast before: digital circuit, electric circuit theory, which is from Elektrische Kreatie and Digital Technique, acquisition system and control systems, frequency response, which require Fourier series, Fourier transform, Laplace transform. I will explain about amplifiers, physics related to the semiconductor theory, diodes, and MOSFETs. Software again, LT-Spice. Here a nice picture to show how the software of LT-Spice looks like. We have practically window where we draw the circuit, and the software is able to simulate the circuit that we drew here. We have EasyEDA, which is printed circuit board design software. So we are able to design a printed circuit board by using EasyEDA. And you can see here we can design, we can have a 3D view of the PCB you are designing. This is called layout, and this is the schematic from which you create the layout. So in the software, you will see that the first step is drawing the circuit of the schematic with the symbol of the components. Then a simple button here in the software will generate this kind of like view here. Then you just need to connect the component between each other, as is suggested here by this line created by Isieda. And once you connect them all, you can have a 3D view that is given by the software, and you can see how it should look like then the final PCB. MATLAB, we will use it for processing data. In particular, as you can see, I will teach you, or at least you have to learn how to plot some nice data plot like this, which maybe come from your measurement in the lab or come from the simulation that you do in your software. So it's used for having scientific plot, which definitely you have to use in your final report for your final project here of this course. And unfortunately for you, let's say, or this is at least the feedback um, I got from some students, is that they didn't like much coding. But again, in this part, in this course, I'm not teaching. I don't want to teach about coding using the software to code and create this plot. But you have to. I will provide you already the code done for plotting. You have to just change maybe the name of one file and then automatically upload the plot. But you also have to understand what is the code means, because if we need to modify a few parts in order to fit your purpose, then you need to know what this code means. So I definitely suggest you to learn the syntax of MATLAB. And finally, we have what is called Tinkercad, which is an online software. I indeed forgot that also Isieda is an online software, so you don't need to download it. You can just register for the website in the website, and then you can use all the software free. And also Tinkercad. Tinkercad is used in this course because we definitely need the software to draw how to build circuit on PCB, on breadboard, sorry. This support, which have a lot of holes inside, is called breadboard. And it's usually the support where we build electric circuit, for example, simple prototype. Once we have tested the circuit on the breadboard, then we create the PCB. Why do we need to use before the breadboard and then PCB? Just because in the breadboard it's much easier to connect and disconnect component. Instead, in the PCB, once you solder the component, is much more difficult and time consuming to desolder the component. So this is very using PCB and breadboard is very good for creating fast prototype. However, when you realize this breadboard thing, then you need to know very well how to connect the wires. Like for example, here, this line here represents wire. So you need to know very well how to connect them. So it's always nice to go to the lab with the paper where there is this picture which show how you think you should connect the components in the circuit. In this way, you can just follow blindly your drawing and connect the components as you draw here in the software. You don't have to worry about thinking if you did it right or not. You can think about it the day before, draw this circuit in Tinkercad, as is shown here. Then you go to the lab the day after, and you just connect the components as you have drawn in this software. For the book, again, I said this is the main book, Adel Cedra, Kenneth C. Smith, Microelectronics. Doesn't really matter which is the edition. Here there is the international edition. Any other edition is okay. I suppose you can find it mainly the international edition. I think it's also possible to find in the library, bibliothèque, and so please look into it and get it if you think you need. Usually my PPT should be sufficient and my notes should be sufficient for preparing yourself for the course, but I understand that if you want a book which look into the topic we are going through, then this one is a good book. I mean, this is a book that, to be honest, I've been told from the students is not easy to going through at the first sight. So you need to read it maybe You need to read the chapter that you're interested in once, and then you have to read it again to understand actually what's going on. So don't worry if the first time you read you didn't get all the points explained, because it's a good book. It contains many information, but that is also the problem, because if it provides too much information, then you have difficulty to distinguish what are actually the most important information and what are the less important information, right? Obliques, here I already talked this morning, but again, maybe due to my not fluent Norwegian, you might did not understand a few points. I want to repeat anyway the rules of the obliques for this year, which are slightly different than last year. Okay, in my past experience, what I've seen is that the students like to solve assignment in group, and this is fine to me. Unfortunately, by solving the assignment in group, uh, there is always some students that understood better than other, and then the one that understood less is not um, worrying to actually understand the concepts, but they just want to deliver the obgave or the oblig. Um, and this is not actually good, because then you arrive until the representation of the project, and then I can immediately see if you actually understood or you acquired the concepts during the course or not. So then definitely I try to not penalize anyone, but if I see that any one of you do some very big mistakes or some very big trouble in explaining basic concepts, then I have to take into account, and then your grade will definitely lower down. So in order to avoid this situation, which means avoiding that you actually do the assignment in group, because this is what I've seen from my experience is not recommended. I do not recommend it, because again, some of you may not acquire the knowledge that you should. I develop an alternative method for this year, and the method is the following. I prepare a group of more than 30 questions for each oblique, and Canvas as a built-in system which can select 6 or n number of questions randomly, where n can be 1, 2, 3, 4, 5, 6, 7, whatever. So in this case, in our case, I set the canvas to select just 6 questions from this list of 30 or more questions. And there will be 2 simple, 2 medium, and 2 difficult questions. And the selection of this question will be totally random and will be up to Canvas actually. And this means also that you will have, all of you, probably different questions for the oblique. Again, the level for each oblique will be the same. I made in order that the questions are at the same level, but you probably will have different questions. In this way, I try to discourage copying or doing this one in group. Again, I'm not against doing it in group, but again, I want to avoid the situation in which you actually do not learn what you should. So this is the most I can do actually for helping you in learning all the concepts that are explained in this course. It's not to make it difficult, but it's just because, again, I want to every one of you understand very well all the concepts. And also because I think in the past I've given obliques of 20, even 30 questions to verify if it actually you went through all of the concepts. But again, in the past, I've got some feedback that maybe it was too much, and then this year, so I decided to have only 6 questions. But again, you don't know which will be. So this means that anyway you have to prepare and you have to understand all the concepts. The oblique probably will remain accessible for 2 days, which means that you have 2 days for opening and finish the obliques. I will set the obliques accessible for specific dates, so you should then try to complete within the time. These dates cannot be changed, of course, unless particular circumstances. Don't worry if you fail the oblique. You can try again, but in the next section. So there will be a specific date, which I call session. And at each session, you can try to do any oblique you want. But only one time you can try for each session. If you fail, then you have to repeat in the next session. Because if I let you repeat many times in the same session, then you will try to repeat it until you get the questions that you want. And this is definitely not what I'm going for, right? So you have only one trial for get it right for each session. If you fail, do not worry, you have the next session to try again for the upgave. The oblique will be only passed with all correct answers. And this is because, again, you have only 6 questions, of course. Again, in the past, I give 30, 20, and they were all able to finish them all. This year I give 6. So I'm definitely requiring that all the exercise will be correct. All the possible questions that can appear in the oblique are listed in Canvas. So you can prepare yourself and try to train yourself to solve them. So then you will be prepared for the oblique. And this kind of like exercise or questions are those one that we seen before in Canvas, which were called preparation to the oblique. Again, the questions that you will get from Canvas may have different numerical data than the one listed in Canvas, than the one in preparation for the oblique. So this means that the type of questions is totally the same of the questions listed in Canvas, but they might have different number, just to diversify a little the question. But the type is the same, so the method that you have to use it, you can look into the Canvas preparation to the oblique. Again, I want to remind all of you that cheating is not allowed. If I found someone cheating, then I won't consider that oblique. I will consider the oblique failed, and I will not give any chance to repeat the oblique, which in other words means that you won't be able to do the written exam, because all the obliques need to have Gaussian. Need to be Gaussian. So think multiple times before to cheat, because if I discover it, that's not good for you. Yes. So in case I have doubts of maybe someone you cheat, or for example, it happened that the writing of the students might be too difficult to read for me. We have different calligraphy, right? So I'm also writing very badly. So I understand that you should understand me that I might also ask you some clarification about the answer you give, just to verify that you have understanding about how the oblique was solved. So I get the freedom to ask maybe one question regarding my doubts that you have in the oblique that you solved. Procedure to access the oblique will be shown in the next lectures, because I almost finished to prepare the questions, so then I will upload them and then I will show you how to access them. Again, you will not be admitted if to the final exam if you don't have all the obliques Gaussian. For the labs, we already saw the labs. I already described to you the labs. We have the first one should be about measurement instruments. So you will touch with your hand oscilloscope, multimeter, and the signal generator. The second one, LT-Spice. The third one is IEDA. I would say that the second one and the third you don't actually need to come to the lab, and that's probably good for you because you minimize the contact with other students and you will be less in risk due to the situation of the COVID. But number 4, definitely need that you come to the lab because there will be the fabrication part, and then you need to fabricate a PCB, a printed circuit board, based on the design that you've done in lab 3. Lab 5 is about operation amplifier, lab 6 also, lab 7 about some parasitic phenomenon, something strange in the circuit we are going to explore happen, and there is no apparent reason, but then if you look into it, you can see that actually there is an electrical source of noise or other parasitic phenomenon. Lab 8 is about diodes, and then lab 9 is about MOSFET, which is not mandatory. All the lab need to be Gaussian, except the number 9. To perform the labs, you will be divided in a group of 2. You can decide your own team member. Usually what happens is that the groups that have been used for the labs that are also the same for the final project. For this year, in this year, the moments in the lab will be limited in order to limit the contact between each other. For this reason, went to the lab, and I'm looking to the placement of the tables. I have created a plan where you are far from each other, at least 2 meters, and there will be only 1 student per group to do the lab. Yes. I will give you more information later on before the lab because I still need to figure out how to make this one more feasible as possible. My idea is to provide you all the components in one box, and everything will be so each group will have one box, and so with all the components, so you don't need to stand up. Once you sit, you remain sit until you finish the lab. Of course, you can go to the toilet and whatever, but you might be assisted by the lab assistant for the movement inside of the lab. If you miss some electrical components, do not stand up. Ask the lab assistant, which will provide you the component. If you miss some lab, you have to send an email before the lab to inform me or the lab assistant. Then you can agree about a specific time with the lab assistant to perform the missing lab. So this one has to be done probably outside the normal schedule. Or you can decide to do 2 labs on the same in one day. I already communicated with our staff for cleaning, to clean all the tables, to provide you antibacterial spray, cleaning equipment, to clean everything you can imagine you want to clean. So then feel free to use it, and do not be shy if it's finished. Just ask and I will provide more. So yes. Again, you will not be admitted to the final exam if you don't have all the labs have been Gaussian. Undervisning, as I said before, we have 1 hour per week. I want to do this undervisning in Zoom. In this undervisning hour, I will try to resolve the exercises and also maybe solve some of the questions in the preparation for the oblig. Yeah, and you have also PDF and video, which can support, provide further support in Canvas. Project. Okay, here finally I can give you some maybe more hint about what could be the project. The idea that I have this year is to realize an heartbeat system, reading out system. I think many of you know about it. It's a device which kind of measure the heartbeat by measuring the pulse rate on the finger, on your finger. So there will be to design an analog front end. There will be to design analog to digital converter, matching circuit, because we might want to implement a wireless communication system. But again, it depends on the situation that related to the COVID virus, because if we have some more restriction, then I have to change this project. And so is at the moment the topic is this one here, but I have also plan B, which I will not mention now because it depend if we will have any constraints during our project work. The project weights 60% of the final grade, and 40% will be instead for the schriftly exam, written exam. If there are any conflicts between two members of the same group, this should be discussed with the teacher ASAP. I've been in a previous experience in contact with some students that had some conflicts between each other, and this was brought out too much late, so at the day of the oral presentation, and in that case, we couldn't do much actually to discriminate who worked more, who worked less. And this is kind of like maybe frustrating for the student that has worked more, maybe because maybe the other did not contribute at all. So if this situation happens, please inform in time. I mean, it can happen that there are conflicts between students. We just need to take the correct method to deal with it, right? You will not be penalized, both of you, both of the members that are part of that group that have some conflict. But we will implement some technique that will solve this problem. For example, split the group and each member will work independently, or we'll just rearrange the groups. So we will let you join with other groups. Again, if this problem is highlighted too late, then I cannot do much for it about it. At the end of this project, you have to prepare a project report written in IEEE template, prepare an oral presentation in PPT, 15 minutes of presentation, 15 minutes of question, or approximately that time. The evaluation will be performed by using an objective graduating scale. This means that we have some particular characteristic that the report and the presentation has to fulfill. This one will be filled on a table, which will be available on Canvas, and all of you can see how much we grade, how much is the percentage of the grade will be for each of these characteristics. So let's say, for example, quality of the plot will have maybe 10% of the grade, quality of the oral presentation, 10% of the grade. These are just example. The real table will be uploaded on Canvas, and so on. So quality of the written report, like if you have a grammar error or something like that, maybe 5%, and so on. The evaluating scale again will be available in Canvas, so then you will see what is the different percentage. This one in order to give an objective grade, right? So there will not subjectivity. It's not because I don't like you, you don't like me, you get less grade, right? So if we follow all this evaluating objective scale, then we should avoid all of these subjective conflicts. Exam, finally, we're thinking about to do the exam digitally. However, we have also requested to do it physically here to our exam contour. However, we are waiting now the answer from the exam contour, and as soon as we get it, we will let you know if will be digitally or physically. If it's physically, for us, it's better because then we can provide a similar type of exam as we did the other years. Otherwise, if it's digitally, we have to think a few techniques to avoid possible cheating and to make the test as most fair as possible. If in the case that is digital, you will have a little more difficult problems because in that case we have to test actually your understanding about the concept learned during the course. Book and notes are allowed during the exam, regardless if it's digital or physical form. It's not a big deal, but that's because the question usually they require that you understand, not memorize. The problem you will face in the exam, they will not be the same that you have seen during the course. The method that you have to apply is the same that you have studied during the course, but the problem will be different. So only if you really understand the concepts, then you will be able to decide which is the best method to solve the problem. Before the end of the course, of course, we will do some preparation for the final exam. Okay, that's all. I think this video has gone also longer than what I expected. Thank you very much for your attention. If you have any question, please send it to me for email. Provide your feedback about also this lecture. About this video. I think this one is a good idea, but again, if you give me your feedback, I will understand better how this video is perceived. If it works, then I will continue to do them. Otherwise, I will just focus more on the forelesning in class. My email is luca.marchetti@usn.no. So I maybe add this information later on in this part. So if you have any question, feel free to ask. Again, I want to also emphasize one thing before I finish this video. During the course, we will study many concepts and difficult concepts. In the time that we have available, it might seem overwhelming, and I can understand that, but this is the program that has been established for this course. I did not decide that. It was like this even before that I started to do this course, and it's actually the same curriculum is adopted in all the other universities. So is a known course in any university that is kind of difficult. But for this reason, and also because the time is limited, feel free to ask questions during the lecture. So please ask questions. It's very important because you won't have time like the other courses to look by your own and try to solve all your doubts on your own. I definitely encourage you to be independent. So try to look by yourself first. But if you see that you don't get the solution, or you don't find a good reference where you can find when you can search the method or the circuit that you want to analyze, then please come to my office or send me email and ask me questions about your doubts. is very, very important. Every year I try to say this. Not many students, they do it because they are probably shy. I think we are all kind of um, grown up, so don't be shy. Uh, Come to me or send me a message and write about your doubts related to the topics that I explained in the lecture, or any other electronic circuit related topic. It's very important. I cannot stress enough about this, because if you try again to do all the course by your own, and you have doubts, then you will bring your doubts forward with you until the end of the course, and you will not understand maybe the last concept that will be explained during the course. So this concept is very important. So all the concepts that you have in this course, they are all related with each other. So if you are not able to understand the first concept or the second concepts, forget to understand the other one. They are all related. So if you don't understand the first concepts in particular, then it will be very difficult that you will understand how the course will proceed. So again, this course requires a lot of effort from you. This one I know. I've been talking with the students many times in the past. I'm very happy to talk with the students for getting feedback to improve this course. In the last 3 years, I always had something to improve based on your feedback. I think it's very important, your feedback, in my opinion. This video is a result, for example, of the feedback of your past colleagues. So please feel free to contact me whenever you want. Okay, but I think I said enough for this video. So thank you very much for your attention. We'll prepare the next video with the first lecture about digital elektroniske kretsar med transistorer soon. I think for this lecture is done. Wish you nice days, and see you next time.